Hello everyone, myself Dr. N. Gopinath, Assistant Professor, Department of Computational Intelligence, SRM Institute of Science and Technology, Katangalathur campus. So today we are going to see few topics which falls under Unit 4, Medium Access Control. Let us start with the introduction of medium access control, that is an overview of the data link layer. So the first purpose of the data link layer is to provide reliable data transfer across a physical link. The key responsibilities are framing, physical addressing, flow control, error control and access control. It is divided into two sub-layers. First one is logical link control, in short LLC, and the second one is medium access control, in short MAC. So let us start about the introduction of medium access control. It is a networking concept at the data link layer, that is the second layer in the OSI architecture, that governs how devices share a communication channel. It minimizes collisions, ensures efficient transmission, and uses unique MAC addresses for accurate data delivery within a local network. So the characteristics of medium access controls are uniqueness, length, representation formats, and structures. First, we will see about the first medium access control methodology, Aloha. Aloha stands for Advocates of Linux Open Source Hawaii Association. It is developed in the early 1970s at the University of Hawaii by Norman Abramson and his team. The goal of Aloha is to connect users across the Hawaiian island to a central computing using low-cost radio communication. The core idea is a random access protocol. So it is decentralized, simple, collision prone and easy to recover. The problem Aloha solves are, let us see with a scenario. Multiple independent stations sharing a single communication channel, that is a radio frequency. Here the challenge is how to coordinate access without a master scheduler. Aloha's radical approach: do not coordinate. Let station transmit freely and handle collisions when they happen. So the key insight here is, for channels with bursty traffic, the simplicity of Aloha can be more efficiently used for scheduling. So here is a diagrammatic representation of how the Aloha format is working. So here the algorithm for Aloha is given. Transmit immediately. Whenever a station has a frame to send, it transmit the entire frame without any delay. Second one, listen for acknowledgement. After transmitting, the station waits for an acknowledgement from the receiver. If the acknowledgement is received, that is, the transmission was successful, the process is complete. If no acknowledgement received, that is time out, it is assumed to be a collision has happened in between. So here is a diagrammatical representation of how the Aloha works. Pure Aloha, the vulnerability period. This is a critical concept of understanding Aloha's performance. Here the question is, for how long is a transmitted frame vulnerable to collision? For a frame of transmission time t seconds, it is vulnerable from the moment it starts being sent. If another station starts a transmission with t seconds before its start time, the two frames will collide. If any other station starts a transmission with t second after its start time, then more number of collisions will happen. Here is a diagrammatic example which is given for the previous scenario. Throughput and efficiency. Throughput S is a fraction of time the channel is used for successful collision-free transmission. So theoretical maximum efficiency. Throughput is maximized when the offered load is G equal to 0.5. So the famous result, the maximum throughput of pure aloha is S equal to 1 by 2E, which is approximately 0.184. It means that pure aloha can only achieve about 18.4 percentage. Slotted aloha, an enhancement version of the pure aloha, proposed by Robert in 1972 to double the efficiency of pure aloha. So the key concept is to introduce the time slots. Time is divided into discrete slots of equal size. Each slot is equal to the frame transmission time T. All stations are synchronized to the slot boundaries. A station can only begin transmitting at the beginning of time. So here is a diagrammatic representation of slotted aloha. Next is the protocol and vulnerability. When a station has a frame, it must wait for the beginning of the next time slot. It then transmits the entire frame. The acknowledgement, collision, or retransmission process is the same as pure aloha. Vulnerability period equal to T seconds. Slotted aloha's throughput and efficiency. Here, the slotted aloha's efficiency is about 36.8 percentage. Previously, it was around 18. So the enhanced version of pure aloha, that is slotted aloha, is providing us the double the efficiency, which is about 36.8 percentage. So here is a major difference between pure aloha and slotted aloha, which is given in a tabular format for your reference. Next, we will move on to the classic Ethernet protocol in the name of CSMA or CD. Local area networks with a shared broadcast medium. That is the context of CSMA or CD. The problem is multiple devices connected to the same segment. How to allow fair and efficient access without a central controller. And the goal, a protocol more efficient than Aloha for a wired environment is expected. So the solution is CSMA CD. That is, it combines the three key ideas. First one, carrier sense. Listen before you talk. Next one is MA, that is multiple access. Many devices share the medium. And the third one is collision detection, CD. If any collision found, it has to be detected earlier. So the core principle of CSMA CD is listen before while talking. So the analogy is given here. A polite conversation in a room. Carrier sense, you wait for a pause before you speak. Multiple access, everyone in the room can speak. Collision detection, if you and someone else start speaking at the same time, you both stop. Wait for a random time and then try again. So the technical translation is this analogy maps directly to the CSMA CD concepts. Okay, here is a step-by-step walkthrough. Step 1. Is a frame ready? If yes, proceed. Is the channel idle? That is carrier sense. Suppose if it is no, wait until the channel becomes idle, then proceed immediately. If the result is yet, proceed to transmit. Begin transmitting frame and monitor the channel. Is a collision detected? If the answer is no, continue transmission until the entire frame is sent. That is success. If the collision is detected, yes, proceed to the collision handling procedure. Upon detecting a collision, continue transmitting a short predefined jam signal. This ensures all stations on the network detect the collision. Stop transmitting the frame. Increment a retransmission counter. Check the counter. If the maximum number of atoms is reached, report it as an error. If not, calculate the random time. So here is a flow diagram of how the CSMA CD will work. So the binary exponential backoff algorithm. The purpose is to ensure that stations involved in a collision wait for different random times before retrying, preventing repeated collision. How it works? After the nth collision, the station chooses a random number k from the set where k is the minimum from n to 10. The waiting time is k into slot time, and the slot time is defined as a fundamental network parameter. And here is a IEEE 802.3 frame format for CSMA CD. The fields are preamble 7 bits, start frame delimiter 1 byte, destination and source MAC address 6 bytes each, length and type is 2 bytes, data and path 46 to 1500 bytes, frame check sequence is having 4 bits. CRC is used for error detection, and this is a pictorial representation of the IEEE 802.3 Ethernet frame format. So advantages and disadvantages of CSMA CD. So the advantages are decentralized, simple and robust, no central control needed. Fairness, the backoff algorithm gives all stations a statistically equal chance to transmit. Efficient for modern load, much more efficient than Aloha protocols. And the disadvantages are inefficient under heavy load, non-deterministic, limited network size. So, as of now, we have seen about the few concepts of medium access control. So we started with the overview of data link layer, followed by MAC address introduction and the methods of MMAC, Aloha, pure Aloha, slotted Aloha, and we move on to the another topic, that is the classical Ethernet protocol, that is CSMA CD, with a simple example for our understanding and a step-by-step walkthrough and the flow diagram of how the CSMA CD is working on, followed by an algorithm, that is binary exponential backoff algorithm, that is the base for the working of CSMA CD, and finally we ended up with the frame format of CSMA CD, that is IEEE 802.3 with advantages and disadvantages. So in the upcoming slides we will see about some other topics which falls under computer network subjects. Thank you.